Hello, this is Jason Ott, and today I'll be demonstrating my final project for Computer Science 110, Fall 2014. This is going to be a project based on the turtle module, using it to draw the skeletons of various regular polygons. We'll be showing you the code first here. So the code for the program is in two major modules. We have the shapes.py module and the platonic solids.py module. The Shapes module does the work of importing the turtle module itself, along with some necessary functions from other modules, the sine and the radians function from the math library, and also the random integer function from the random library. As you look through the module here, you'll see all the basic shapes that we'll be using to construct the polygons are all right here, along with some other functions we'll be using to find the center of regular polygons, center poly function, and then also we have the sunburst, circles, triangle hex, figure eight, pentastar functions that are all used for drawing designs inside the 5 basic regular polygons. The platonic solids module actually contains the meat of the program. It first imports all the information from shapes, so it also will import the functions that were previously imported there. And then it starts off with definitions of the tetrahedron, the cube, the octahedron, icosahedron, dodecahedron, the truncated icosahedron, and the great dodecahedron, each defined in there, and then ends up with the main function here, which has a interface for the user, which will ask them which shape they would like to draw, and then use a decision structure to draw the actual shape. And at the end, we'll allow them to choose to draw additional shapes rather than just quitting the program after using one. So from the project here, we're going to go ahead and open the platonic solids file. It asks you which shape you'd like to draw. We'll start off with the tetrahedron. So it calls the function, which brings up a window, which is sized to take up the entirety of the screen. Takes the turtle and begins to draw the triangle polys. You'll notice the designs inscribed inside the polygon, they each have different orientations. This is taking advantage of the random integer generator, calling a number from between 90 to 360 degrees and adding that to the full circle that it draws. So each one of these has a unique orientation, making the shape a little bit different each time that you create it. Once the shape is finished, it will stay on screen until you actually follow the instructions to click the window to exit, at which point it will return you back to the main function and give you the chance to draw another. So moving forward, we have the chance to draw another polygon now. So we're going to hit yes, and it will bring back up the list here, give you the chance to enter another one. So we'll go to the cube now. So again, it'll bring up the full screen. With the cube, you notice it uses a new design in the center. This one's made by using the circle function, taking advantage of the extent parameter to tell you how many times to go around the circle that it's drawing, and then further using steps along the way so that instead of drawing the circle, it actually goes from point to point and gives you this different type shape, a little sunburst we put in here. So this is the cube. Again, it's also been resized by the function being called in the main function of the program to fit within the window here. So we'll go ahead and close this one out, and we can draw another one now. This time we'll do the truncated icosahedron. So this one's a much bigger shape. Now in the course of this one, it uses radial symmetry in the shape so that it draws the arm here with the various pentagons and hexagons, and then returns to the center, moves around to the next point, and then draws the next arm. So it initially draws a pentagon that will be at the center here, and then it will go through the loop 5 times, each time drawing identical arms around the shape. So when it reaches the end of this last arm, it's actually going to, instead of returning back to the center, the condition is going to tell it to draw this last pentagon here that will form the cap of the other ring where the 5 arms all come together. So this will give you your finished shape when you actually print out and assemble it. So for this final shape we're going to draw, we're going to do the great dodecahedron. This one also relies on radial symmetry. It makes 5 identical arms. Now all 5 of these are exactly the same, and this time the center point that it does the drawing from is right here at the center. And each time that it finishes one arm, it's going to return back to the center and then rotate to the next position 72 degrees over so it can do the next arm. Now with this one, you notice there's 2 different types of triangles we're drawing. We did that so it can be a little bit quicker. It doesn't actually have to go quite as much movement between the shapes. It can just flip from one to the other as it goes through drawing the shape. And that's the great dodecahedron. Well, thank you for taking the time to watch this video, and I hope you enjoyed seeing how this project works. Again, this was the turtle module inside Python, used to draw various polygons through programming. And thanks again.